Some people have a special way with other living things. They seem to understand them, even relate to them. You've heard of horse whisperers and maybe even dog whisperers. Well, in this episode's profile, here's a scientist who's tuned into some creatures I guarantee you have never talked to. In fact, you can't even see them. She's been called the Bacteria Whisperer. But with a whisper is never how BonnieBassler starts her day. This MacArthur Fellow, and prestigious Howard Hughes medical investigator, and member of the National Academy of Sciences, starts each weekday in aerobics class. As the teacher, of course.
I have been teaching aerobics for 23 years, more than half of my life. And everybody thinks, oh, I'm so committed to this and I'm so disciplined. And it's a big scam because I would never go if I wasn't a teacher.
But Bonnie is a teacher to the core, in aerobics and in molecular biology at Princeton.
Who wants to talk to me about science?
Where she also wants to see some sweat.
5 or 10 minutes, get some science. If you want me to do it for you,
yeah,
I won't, because it wouldn't kill you to learn a little genetics. Come on, you guys!
In fact, ask Bonnie about bacteria, and she just can't help teaching.
Bacteria are single-celled organisms. Bacteria are the model organisms for everything we know. In higher organisms, there are 10 times more bacterial cells in you or on you than human cells.
Bonnie and her lab work on how bacteria talk to each other. That's right, bacteria talking. It's a process called quorum sensing, and Bonnie's lab has been leading the way in understanding exactly how it works.
She's really the one who's shown that this is something that all these bacteria are doing all the time, and if we want to understand them, we have to understand quorum sensing.
So I grew up some bacteria for you to see, and I want to show you my favorite part, so you have to come with me in this room.
Bonnie has spent years studying Vibrio harvii, marine bacteria that are harmless to humans, and, triggered by quorum sensing, glow in the dark. By themselves or in small numbers, these bacteria don't glow. They wait until they've assembled a quorum. That is, as they divide and their numbers increase, they each release a signaling molecule.
We call autoinducers, but you can think of like hormones.
That's made by a gene in each of the neighboring Vibrio harvii, as a way of announcing, hey, I'm here too.
They have these detectors on their membranes that you can think of like little locks and keys, and the molecule goes in, and once they feel that, then they know there's neighbors around.
And when enough of these little guys have gotten together to form a critical mass, they all light up at the same time.
And so now if I turn the lights off in the room, you're going to see them make this beautiful bioluminescence.
One bacteria isn't able to make an impact by itself, but if there are a lot of them, they can work together. So quorum sensing is the way they know, are there enough of us to undertake one of these group activities?
It's incorrect to think of bacteria as these asocial single cells. They are individual cells, but they act in communities exactly the way people do.
Bonnie was doing her postdoctoral work when she found the genes that allow for communication in Vibrio harvii. And scientists from around the world yawned. Because Bonnie's discovery was only in this species of marine bacteria, and not in one that's dangerous to humans.
There's these few bacteria that were models, you know, E. coli, Salmonella. And if you didn't work on the models, then you worked on a pathogen, something that was important for human health. And so this quorum sensing, which we didn't even call it this back then, because it was in this luminous bacteria that doesn't even hurt a fish, it was never going to be relevant for understanding either bacteria or higher organisms.
But Bonnie believed otherwise. She thought her bacteria could tell her more about how all bacteria communicate. So she applied for a job to continue her work in quorum sensing.
Oh, I applied to a lot of places for a job. I don't know, 20 or 30 or 40. And I got 2 interviews and 1 job.
Yeah, but that one job was at Princeton University.
I was chair of the committee that hired BonnieBassler. I know people at other places, and I don't want to name names, but one of them said, "Why did you hire her?"
Let's just say she did okay by landing at Princeton. And Princeton's belief in Bonnie had a huge payoff. Her lab eventually discovered a second molecule used by her luminescent bacteria to communicate.
Oh, that's actually pretty cool.
And this second molecule was nearly universal.
We found it originally, of course, in Vibrio harvii, but then we could show that hundreds of other bacteria made and used this molecule and that it was in every bacterium anybody's heard about.
That means that even dangerous bacteria communicate by quorum sensing. Deadly pathogens turn deadly the same way that Bonnie's bacteria turn on their light. Bonnie showed that there are two types of molecules that bacteria use for communication. That bacteria are bilingual. One type of molecule is used for communicating within their own species. And the other type, discovered by Bonnie, is used to talk to every species around them.
Bacteria live in unbelievable mixtures of hundreds or thousands of species. Like on your teeth, there's 600 species of bacteria on your teeth every morning. And so in order to get these beautiful communities where they're working together and doing all these things, they have to know who their neighbors are.
And some of those neighbors are not friendly. Using the molecule found by Bonnie's lab, bacteria know if they're surrounded by friend or foe, or when it's safe to light up or attack. If they don't have superior numbers, they won't act. Sometimes they team up across species, but mostly it's a tiny jungle out there.
There's eavesdropping and free riding and cheating, and one guy is out there making a molecule and the guy next to it eats it, so the molecule disappears.
My gosh, these bacteria talking to each other across species. And that's something that had really not been an accepted idea. This was sort of just a crazy idea.
So remember,
What Bonnie did to show that different species of bacteria could talk to each other really changes the landscape. And when that was realized by the rest of the scientific community, Bonnie's career took off like a rocket.
But Bonnie was not launched by a scientific family.
we never talked about science. You know, my mom was a stay-at-home mom, my dad was a businessman, and my brother's a businessman, and my sister's in politics, right? So we're just all over the map.
She moved around a lot as a girl, but was always kept grounded by her mother.
My mom was the linchpin of this family, and I remember her saying things to me like, you know, when I went to college, you could be a teacher or a nurse. Those are your two choices as a woman. She goes, but Bonnie, you could be anything you want.
Bonnie's mother died when Bonnie was just a junior in college.
And I remember her telling me when she was sick that she would take all the steps the same. So I think she got payoffs, even though she didn't get the ones that, like, you know, that the world sees as the payoffs, right? Because these are like very, they're tangible, acceptable things. You know, the MacArthur, the National Academy, Howard Hughes, those are things that you can write in a Christmas card, right? And she just would have written other things.
Big things like Bonnie marrying actor Todd Reichert. Little things like mercilessly beating her husband and colleagues at board games. Biologist Eric Wieshouse won a Nobel Prize, but this night lost to Bonnie.
I've taken enormous pride in what she's accomplished. I would argue that our committee just did one hell of a fantastic job.
But, as Bonnie sees it, her work has only just begun. Quorum sensing is helping to shape a path to new drugs. Antibiotics currently work by killing bacteria, and more bacteria have grown resistant to these drugs. By using quorum sensing, it may become possible to disrupt a pathogen's communication, to neutralize it. For the foreseeable future, that's where Bonnie and her team will be putting their sweat.
I want to make a drug. I want the science to be more than imaginary, where I think we're learning these fundamental principles, blah, 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 blah. I think we are doing that, but I want to do something really practical. I want to actually, in my lifetime, help people.